So imagine you are standing on a loud, high-stakes industrial floor.
Right.
Let's say it's a sprawling oil refinery. The machinery around you is just deafening. The steel pipes are pulsing with thousands of pounds of pressure, and you're about to perform a maintenance task where, honestly, a single misstep could trigger a catastrophic chemical release.
Oh, absolutely, which costs millions of dollars in downtime.
Right. Millions of dollars, or, worse, it could cost lives. Now, imagine your mentor, the veteran, who has done this exact highly dangerous task perfectly for 30 years, just retired last week.
Yeah.
And you are staring down at a digital tablet with a checklist. So the question is, who is watching your back?
Well, the terrifying reality for the industrial sector right now is that in a lot of cases, the answer is nobody.
Wow.
The person who used to watch your back is simply gone, and they aren't coming back.
Which brings us to today's deep dive. We are pulling from some very compelling source material to figure out how the industry is trying to survive this massive shift.
It's a huge shift.
It really is. We're looking at a recent press release and some detailed excerpts from a white paper by EON AI Ventures. It's titled Field IQ, Redefining Industrial Safety with AI Copilots. And our mission here is to explore an incredibly ambitious technological gamble.
Yeah, and it's a gamble about solving a demographic crisis by strapping artificial intelligence directly to the faces and wrists of field workers.
Which sounds completely wild.
It does. But it forces us to look at a fundamental shift in how human beings interact with machines, We are moving away from passive tools like, say, a tablet that just sits there waiting for you to tap a screen.
I might the static tool.
Exactly. And transitioning to active copilots that monitor your physical environment and intervene in your physical actions in real time.
Which is huge.
It is. Even for someone listening to this who will never set foot on a factory floor, the mechanics of how this tech bridges the gap between human intention and physical action, it's going to reshape the tools we all use in our daily lives.
Okay, let's unpack this core crisis driving the tech. Because to understand why a company needs a sci-fi sounding AI copilot in the first place, we first have to understand the human vacuum they're trying to fill, right?
Right.
The white paper refers to it as the silver tsunami, which is quite the term.
It's fitting, though. They are projecting that nearly 50% of expert technicians are going to retire in the next 5 to 7 years.
Wait, 50%? Half the workforce?
Half the workforce, just gone.
That is wild.
And when a specialized workforce ages out at that volume, the primary loss isn't just manpower, it's an ocean of undocumented institutional knowledge.
Yeah.
The white paper focuses heavily on these high-stakes, routine tasks. Procedures like lockout, tagout, valve calibrations, hot tap preps.
We should actually pause and define what those are, just to ground the stakes here for everyone listening.
Sure.
Because lockout, tagout isn't just, flipping a light switch.
No, not at all.
It's the strict physical procedure of putting a literal padlock on a breaker box so that someone else doesn't accidentally turn a massive grinding machine back on while you are inside it performing maintenance.
Exactly.
And a hot tap prep that is essentially drilling into a highly pressurized pipe while it's still pumping volatile chemicals without shutting the entire system down.
Yeah, the margin for error is absolute zero.
Wow.
These procedures rely on highly nuanced muscle memory. A 30-year veteran knows by the subtle resistance of a wrench whether a high-pressure valve is seated correctly.
Right, they can just feel it.
They feel it. But a new hire simply does not possess that tactile vocabulary. So to bridge that gap, the industry's current default is handing that new hire a digital tablet loaded with PDF manuals and step-by-step checklists.
And the white paper is brutally critical of that tablet approach, right?
Well, yeah, very critical.
They call it a reliance on static instructions. The tablet might have all the correct steps for that dangerous hot tap prep, but it's completely passive.
Yeah.
I keep thinking about this like using a recipe app on your phone while baking.
Okay, I like that analogy.
Yeah, so the app clearly tells you to add a teaspoon of salt. But if you get distracted and reach for the sugar instead, the phone just sits there.
It doesn't know.
It has absolutely no spatial awareness to stop you. It just assumes you followed the instruction perfectly because you scroll down to the next step.
What's fascinating here is when you consider the industrial equivalent of reaching for the sugar.
Right.
In a refinery, grabbing the wrong item might mean turning a high-pressure release valve instead of a containment valve.
Which is a disaster.
Exactly. The fatal flaw of a tablet is that it's blind to the physical reality of the job site. It doesn't know if the worker is standing in front of the correct machine or holding the correct tool or following the sequence safely.
It's totally blind.
Yeah, so the worker is left to interpret the instructions in total isolation. And in an environment where a momentary lapse in concentration leads to massive facility downtime, or worse, relying purely on a solitary worker's interpretation of a static checklist is just a profound liability.
So if the tablet is blind, the obvious technological leap is giving the instructions eyes.
Precisely.
We need a system that actively watches and intervenes. And that leads directly to the mechanism EON AI Ventures has built. According to the release, Field IQ is the first end-to-end AI copilot built specifically for industrial fieldwork.
Yes, and it's powered by what they call the Genesis platform.
The Genesis platform,
Yeah.
okay.
And the architecture of how a worker interacts with this platform is what pushes it way past a simple digital upgrade. Field IQ utilizes vision-aware and voice-driven guidance.
And this is delivered through the Meta Ray-Ban display, HUDs, right, the heads-up display.
Exactly. We were talking about highly sophisticated smart glasses. So a worker walks onto the floor wearing these, keeping their hands completely free to hold their tools.
That makes sense.
The documents detail how a worker can walk up to a complex tangle of pipes, look at a specific physical object, and the glasses immediately identify it.
Just by looking at it.
Just by looking. The example in the paper is valve V204 on skid SKD104.
And a skid, in this context, is just a modular steel framework holding heavy machinery, right?
Yeah, exactly. So the worker looks at the skid, and the AI overlays task-specific directives directly into their field of vision. Or the worker can just ask out loud, hey, what's the next step?
That is so cool.
It is. The system dynamically adapts to the physical environment by seeing exactly what the worker sees. But the true breakthrough and the metric that really makes this viable in a hazardous environment is the intervention speed.
Okay, I want to get to this.
The white paper highlights a pre-contact intervention time of 200 milliseconds.
200 milliseconds. We need to dissect the physics of that claim because human beings blink in about 300 milliseconds.
Right.
If a worker reaches for the wrong valve,
Yeah.
you're telling me this system sees the hand moving, processes the error, and stops them in a fifth of a second.
That's the claim.
How does it even bypass the latency? Because normally, an AI tool has to send visual data up to a cloud server, process it against a huge database, and beam the answer back down.
Which takes way too long.
Yeah. By the time that happens, the worker has already turned the wrong valve and blown the pipe.
Well, the mechanism enabling that speed relies on localized processing, often referred to as edge computing.
Edge computing.
Right. To achieve a 200 millisecond response, the system cannot rely on a distant cloud server. The critical safety parameters and the visual recognition models have to be processed at the edge of the network.
Meaning right there where the work is happening.
Exactly. Heavily on the headset itself or on a localized network node just feet away on the factory floor.
Oh, wow. So it functions kind of like a human reflex.
Yeah, that's a good way to put it.
Like if you touch a hot stove, your hand pulls back before the pain signal even reaches your brain. Your spinal cord processes the danger locally and fires the muscles.
Yes.
So this AI is acting as a localized spinal reflex for the factory floor.
That's exactly it.
If the worker's hand deviates from the prescribed safety path, the system triggers visual S.P cards right in the heads-up display. It blasts audio cues into their ears, and it delivers haptic feedback like a physical vibration through a device called a neural band worn on the wrist.
All in 200 milliseconds.
I mean, I do have to look at this from the perspective of the person wearing all this gear, though.
Okay, fair enough.
I understand the localized processing and the safety imperative, obviously, but are workers actually going to tolerate this?
It's a valid question.
Having glasses flash red and a wristband violently buzz every time your hand drifts feels incredibly invasive. It sounds a bit like having a profoundly nervous driving instructor with a secondary brake pedal.
Right.
But instead of sitting next to you, the instructor is strapped directly to your face and wrist, micromanaging your every twitch.
If we connect this to the bigger picture, the initial reaction might be resistance, sure. But the psychology of pre-contact intervention shifts that dynamic rapidly. Well, think back to the novice worker we talked about, replacing the 30-year veteran.
Right.
That novice is carrying the sheer terror of causing an explosion or ruining $1 million batch of chemicals. By closing the gap between the human intention to move and the dangerous physical contact, the AI actually removes that underlying terror.
Oh, I see. It catches the mistake in the space between the brain saying turn this and the hand actually turning it.
Which dramatically reduces the time to competency for new hires.
Right.
The AI isn't functioning as a nagging micromanager. It serves as a hypervigilant safety net.
That makes a lot of sense.
Yeah, a new worker can walk into a highly complex, dangerous environment and operate with the confidence of a seasoned veteran because they know the system physically will not allow them to make a catastrophic error.
It's like training wheels that actively shift your center of gravity to prevent the bike from tipping over.
Exactly.
I can see how that drastically lowers the stress level on a chaotic floor. But, stopping a mistake in the moment is really only half the battle in these
Oh,
sectors.
absolutely.
In energy refining and process chemicals, you don't just have to perform the job safely. You have federal regulators and safety inspectors breathing down your neck. You have to legally prove that the job was done perfectly.
And that transition from the physical action of the worker to the back-end supervision is where the platform's architecture fully integrates.
Right.
Field IQ generates compliance-ready audit logs automatically. As the worker progresses, the system auto-verifies the steps. It captures photographic proof and time-stamped documentation
Without the worker doing anything.
without the worker ever putting down their tools to snap a photo or check a box.
Here's where it gets really interesting. Because to understand how this alters the whole ecosystem of a factory, we should look at the 4 critical user journeys outlined in the deployment strategy.
Yes, let's look at those.
They don't just drop glasses on people's heads on day one.
No.
First, there's the system setup. The AI uses the headsets to visually map the facility and build a digital understanding of the machinery. Then, the training setup, where workers can practice using virtual overlays before touching the live equipment.
Which is crucial for safety.
Absolutely. Third is the actual field use we've been discussing with the real-time interventions. And the fourth journey is monitoring.
Yeah, and the monitoring journey introduces what the paper calls supervisor visible capabilities.
Okay.
A supervisor sitting in a control room can monitor live tasks as they happen across the entire facility. They can track performance metrics and address any anomalies the AI flags in real time.
That's a lot of oversight.
It is. And the leadership team driving this chairman, Dan Lajerskar, and his team at EON AI Ventures, they bring 25 years of XR experience to this platform.
And XR being extended reality, the technology of overlaying digital information onto the physical world.
Exactly.
That deep background in XR clearly informs their philosophy regarding AI in the enterprise space, right? They draw a very hard line between consumer AI and industrial AI. They emphasize this 100% rule.
The distinction they make there is vital. I mean, we are used to generic consumer AI, like large language models that generate text or images.
Right, the stuff everyone plays with online.
Yeah. Those consumer tools deliver roughly 80% accuracy. They operate by predicting the most likely next word or pixel. If an AI hallucinates a detail while writing an email draft or creates a funny image with 6 fingers, it's a minor inconvenience.
Right, if it hallucinates a poem, it's funny. But high-stakes industrial operations require absolutely 100% precision.
Right.
You cannot have an AI hallucinate the calibration metrics for a highly combustible pressure valve. If Field IQ relies on probabilistic guessing and makes a 20% error on a refinery floor, the result isn't a bad email draft, it's a lethal chemical fire.
Exactly. The system has to be entirely deterministic, relying on fixed engineering schematics rather than creative text generation. The margin for error must be systematically engineered out of the equation.
Every directive must map perfectly to the physical reality of the specific equipment.
Yes.
Let's follow that logic to the control room, though. Because by shifting the entire burden of proof to automated photos and deterministic AI verifications, what happens to human trust?
Yeah.
No. Like, if the AI logs that the job is done perfectly with a time-stamped photo, the human supervisor is highly likely to just blindly accept it. Does deploying a flawless, auto-verifying co-pilot turn human managers into rubber stamps for a machine?
This raises an important question about accountability. It really forces a redefinition of what oversight actually means.
How so?
Under the legacy model, supervisors were forced to be paper-pushing auditors. They spent their days chasing down workers, looking at static checklists, and relying on human memory to verify if a dangerous task was done hours ago.
Right, like, hey, did you close valve 204? Yeah, I'm pretty sure I closed it before lunch.
Exactly. It's a system built on the fragility of human recall. But when Field IQ handles the granular step-by-step verification and captures the photographic proof automatically, the supervisor's cognitive load is completely freed up.
Oh, I see.
They are no longer auditors of the past. They become real-time operational strategists.
That's a huge pivot.
It is. They can look at macro-level operations, spot systemic inefficiencies across different teams, and intervene only when the AI flags a unique anomaly that requires complex human judgment.
Okay, let's pull all these threads together to see the larger picture. We started by looking at a terrifying demographic cliff.
Silver tsunami.
Right, half of the most experienced technical workforce vanishing in the next few years, taking decades of muscle memory with them. And to fill that dangerous vacuum, the industrial sector is abandoning the passive, blind digital tablet.
Yeah.
Instead, they're utilizing edge computing to power a 200 millisecond active safety net. They're using smart glasses and haptic wristbands to guide completely novice workers, demanding 100% deterministic precision over the 80% convenience we see in consumer tech.
We are witnessing a total reinvention of the standard operating procedure. The industry is moving away from the old mantra of trust but verify and adopting a new framework of guide, prevent, and auto-verify.
And to you, listening to this right now, the implications stretch far beyond the walls of an oil refinery. Whether you work in logistics, healthcare, software development, or management, understanding this shift is critical.
Absolutely.
This transition from static instruction to a vision-aware, physically intervening AI co-pilot is not going to stay contained in heavy industry. The technology that learns to watch a factory worker's hands will inevitably bleed into consumer spaces and fundamentally alter how we interact with our own professional tools.
And the integration of this technology leaves us with a pretty provocative question regarding the future of human capital.
Ooh.
Yeah. If an AI co-pilot can perfectly guide, instantly correct, and fully verify a total novice through a highly complex, incredibly dangerous physical task,
Yeah.
how long until our very definition of expertise changes? In a decade, will your professional value lie in the years of specialized knowledge you have memorized, or simply in your willingness to seamlessly execute the physical actions an AI co-pilot maps out for you?
That is a staggering thought to walk away with. Imagine that refinery floor again, the deafening noise, the immense pressure. The 30-year veteran is gone, but the intelligence strapped to your face means you already know exactly what to do. Thank you for joining us on this deep dive into the source material. Keep questioning the world around you, and we'll catch you next time.